Can I call Dr. Parvatam Siva Prasad? So this is an interesting thing actually. Auto advancements and breakthroughs in metal air EV batteries. I think somebody has spoke about chemistry, and probably Dr. Parvatam may be speaking from the metallurgy or metals point of view. I request everyone to be there. This is the last but one session.
Good evening, everybody. I'm Dr. Siva Prasad from Chennai. Advancements and breakthroughs in metal air batteries. One of the ways to reduce the green carbon dioxide emissions is the implementation of EVs. Currently, LIVs are the most predominantly used, and there are certain shortcomings in recycling of because of the hazardous chemicals used. Next slide, please. In this connection, metal air batteries are finding a lot of attention of several workers because they are based on eco-friendly materials, 100% recyclable, low cost and eco-friendly materials. Next slide. One compartment is open air atmosphere, and their cathode is oxygen from ambient air, which leads to significant battery reductions and unprecedented advantages in the many applications. MABs are cheap because of the cathode source abundant and available from atmosphere. It can be made lithium, aluminum, zinc, iron. Such metals can be the anode materials. Next slide, please. Aluminum and zinc are most abundant materials and most favored metal and batteries. Next slide. These are the various applications. Next slide. Here you can see the various metal and batteries. Aluminum air has special attraction because it has the highest volumetric energy density of 23,000 watt hours per liter. Next is, this slide shows the number of patents filed in the globally. Zinc ion is most studied. 1,400 patents have been filed globally. Next slide. This is a representative cell of the metal and battery. Next slide. These are the next slide directions. I will skip the aluminum air batteries. The first battery was developed in 1962, and generally aqueous electrolytes are used. Potassium hydroxide is preferred because of the low viscosity factors. Next slide. There are several challenges, especially for the metal air batteries, self-corrosion and overall catalysts to be developed. Platinum-based catalysts are expensive and next slide. Extensive efforts are needed to explore non-precious metal substitute catalysts. One issue is the next slide. Aluminum air batteries cannot be electrically recharged. The concept of mechanical recharge is proposed. Next slide. These are the advances made. Air cathode, different nanomaterials including single atoms, quantum, metal organic frameworks. Several developments have been made. Some of them are more competitive than, or at least matching platinum metal alloys, rechargeable MABs. Very few studies have been reported. Rechargeable secondary batteries. Some deep eutectic mixtures have been developed for the rechargeable aluminum air batteries. Next slide. Whether aluminum air batteries are comparable to IC engines. Next slide. Trevor Jackson has developed a battery which can single charge 2000 kilometers. It can go in single charge. Next slide. Finergy in 2013 developed a 2000 kilometers range single charge. Next slide. These are the advantages: high energy density, high voltage, safe and better, because they are electrically safer. Because lithium batteries are prone to unprovoked fire hazards, these metal batteries are safer. and recyclable also. Aluminum air battery recycling technology is already available. Existing technologies can be used. Next slide. Sluggish kinetics of OR is another problem, and recharging of the mechanical swapping energy station is should be nearby. Otherwise, there is a problem. Next slide. Aluminum batteries are finding flying applications. As I told you already, it has highest energy density of 23,217 watt hours per liter. Israeli company eAviation is planning LIC electric aircraft business. Trevor Jackson, in a recent proposition, has achieved 46% power increase in their cathode, and this means that they are good for electric flights also. Next slide. Wright Electric Brothers, they are planning a 100-seater aeroplane in 2026. Next slide. EMV developments in India. Hindalco and IOC and Finergy, they teamed up together to make aluminum batteries in India, and IOC planning recharging station through its petrol filling stations for swapping of the mechanical swapping of the aluminum batteries. Next slide. Zinc air batteries I will skip through because of lack of time. Shall I skip? Zinc air batteries are most developed. As I showed in the beginning, 1400 patents have been filed, and rechargeable zinc air batteries also have been developed to a reasonable extent. And mechanical recharging also is the only way initially to be implementing the in the EVs. Next slide. The promising specific approaches, good biofunctional catalysts, address irreversibility of the zinc, flexible mechanism, and electrolytes, different categories are planned. Next slide. Mechanical recharging is the only way for the time being to implement the zinc air batteries in the EVs. Next slide. This is a electric fuel system developed by the electric fuel company of Israel. Next slide. Tesla, one lithium-ion batteries, one Tesla researcher, Jeff Dawn, they developed a 100-year battery which can run 4.5 million, 4 million miles in a single charge. Sorry, 4 million miles before changing replacement. This is lithium-ion battery. Next slide. Global market scenario. Global market for the MABC is around $1,000 million US dollars in 2027. Global million of aluminum batteries is $270 million in 2028. Global zinc air batteries is 607 in 2028. Leading players are the next slide. Indian scenario in zinc air batteries. ITM is working on zinc air batteries using a mechanical recharge concept, and Canadian battery Zincate is tying up with Vijay Electricals to develop zinc air storage systems in India. Two researchers from Bengaluru also developed zinc air batteries using mechanical concept. Next slide. Conclusions. Zinc and aluminum based MABs are attractive for Indian conditions without lithium metal reserves. Catalysts which can perform effectively are essential for cathodes in commercial MABs, and cost effective catalysts have to be developed. Leakages, stability, and thermodynamic limitations are the challenges for MABs, and electrolyte additives are the types of electrolytes can solve or minimize some of the challenges faced by the MABs. Next slide. Aluminum air batteries are of special interest because of very high volumetric energy density of 23,278 watt hours per liter among any battery systems, and are considered next generation batteries for EVs with mechanical recharge concept, including aviation applications. Zinc air batteries are attractive for EVs under considered as an alternative to lithium batteries in view of their high energy density, recyclability, low cost, safety, and mechanical recharging similar to AABs, and also relatively rechargeable rechargeable zinc air batteries are well advanced in development. There are of course several challenges to be overcome for commercialization of AABs or AABs, ZABs, and rechargeable zinc air batteries. Thank you.
Thank you, Dr. Parvatam. Very interesting. May I request Shailesh to give the memento to Dr. Parvatam? नहीं, इसके बाद.
Thank you.